In this video, we're going to be continuing our introduction to gas chromatography and our discussions of the effects of temperature on resolution or improving the separation between compounds. It's important to remember that in gas chromatography, what we're looking at is how long it takes for a compound to move through the length of the column. And in gas chromatography, this is largely based on its volatility. So the retention time and K prime is a function of temperature. Before we can consider its effect on resolution, we need to talk about one more factor, and that is how the width of the peak is affected by non-statistical effects. For example, too much compound. If we put too much compound on the column, normally what you expect is a Gaussian distribution. But with too much compound, when the A tries to undergo equilibria with the surface, if the stationary phase is already saturated, you cannot undergo an equilibrium, and that compound is pushed down the column without getting a chance to interact with the surface. That lack of ability to interact with the surface moves the compound A through the column too fast, so its arrival time is faster than it should be, resulting in a non-Gaussian peak shape, which tends to have a sharp leading edge and tail off for an extended period of time. Putting too much compound on the column results in an increase in the width of the peak and therefore a reduction in the resolution or a reduction in your ability to separate it from other compounds. This same effect can be created if it's on the column for too long, or in other words, it has too high of a K prime. If the compound has too high of an affinity for the stationary phase, too much of it will dissolve into the stationary phase, again creating the same kind of effect as if you had too much compound, pushing it down. And we see once again an increase in the width of the peak or a reduction in the ability to separate things if it is on the column for too long a period of time, if its K prime is too big. So now we can talk about what are the effects of increasing and decreasing the temperature on resolution in gas chromatography. We're specifically going to be talking about what is called an isothermal experiment or gas chromatography that is occurring at one temperature. Suppose we have compounds A and B, and we put them on the GC column, but the column is at too high a temperature. A high temperature means low retention or a low K prime value. It's going to be blown off the column really fast. That means the number of equilibria that A and B are going to undergo are going to be very small because they won't be on the column that long. They won't interact with the column. There will be a few number of equilibria. N goes down, and therefore resolution or separation goes down. If we were to lower the temperature, that means that they would be able to interact with the compound for a longer period of time, and we would end up with our statistical separation because N would increase and therefore R would increase. But now we run into the last problem, which is what happens if we just try to increase N a lot by leaving it on the column for a very long time? Unfortunately, what happens then is you end up with a non-statistical peak shape. So it will be on the column longer, but the peak shapes will tail off, which means if you run it at too low a temperature, you actually lose separation of the two compounds A and B. If you run at too high a temperature, you actually can't separate the two, so there has to be an optimal temperature, which is experimentally determined, that will allow you to get the best separation between your mixture A and B on a GC. This becomes more of a problem if you have a mixture that contains more than two compounds. Let's say it contains 4. And let's say at a very high temperature, A and B don't get separated, but C and D do. So we could achieve good resolution for a couple of them, but the other ones come off too quickly, so there are not enough equilibria for A and B to undergo, so they do not get separated. C and D, having different volatilities, are able to be separated at a high temperature. If we lower the temperature so that we extend the amount of time that A and B have on the column, we can improve the resolution of A and B, but now C and D are on the column for so long that at a lower temperature, that won't work. So here we have the problem of any individual temperature is not going to function for good resolution or good separation of all 4 compounds. But since we are controlling the temperature, we may be able to control the temperature as a function of time. We could start out at a low temperature and let the temperature of the chromatogram exist at a low temperature, and then increase the temperature to a higher temperature. In this manner, A and B would be allowed to come off at low temperatures, and then we would ramp the temperature up to a high temperature, pushing C and D off. So we can run it at the lower temperature to separate A and B, and then the higher temperature to separate C and D. Temperature programming is an experimentally determined temperature that will allow optimal separation of the compounds in your mixture.